Hello, we are starting a new chapter, and the new chapter is going to be on the orange workbook. It's going to be topic 8, and it is kinetics and equilibrium. On this chapter, on this actually video, we're going to study kinetics, and we're going to talk about what is kinetics. And kinetics, that is a new word, that is a Greek word for you, a new Greek word. It comes from the Greek word kinesis, okay, which means movement. And I'll explain it, but for now, kinetics is a branch in chemistry that studies, and you should write that down, that studies the rate of a reaction. And you're going to say, what is a rate of a reaction? Well, it measures or it studies how fast or slow a reaction takes place. And that is very, very important to study, as we're going to see later on, because we're going to see in our everyday life that some reactions take place fast and some are slow. So for example, the rusting of iron, okay? We cannot just sit there and watch an iron and wait, a piece of iron and wait for it to rust. It takes a long time. So that is a very, very slow reaction. How about the combustion or the burning of propane gas? Okay, for example, when you are barbecuing, you're burning something, it takes place very fast. How about the ripening of fruits? That's a chemical reaction. The fruits are ripening. That is a slow reaction. It takes place over a long period of time. How about bleach on clothes? If you wash your clothes and you put bleach, you drop bleach, instantly, what are you going to see? The color of the is going to disappear. So that's a fast reaction. Now, how do scientists measure how fast a reaction takes place? Well, what they do is they measure rate. So what is rate? Rate is change of a variable over time. If you have taken physics, okay, we measure rate. An example of rate would be speed. When they're measuring the speed, how fast the car goes, what do they measure? The change in distance over time. So they may say kilometers per hour. They may say meters per second. They may say miles per hour. Okay? But nevertheless, it's the change of a variable over here. In the case of speed, is distance, the change in distance over a certain unit of time. In chemistry, we measure the rate in the change of concentration over time. And we remember it from our previous chapter that concentration is measured in molarity, for example, over time. And to show that molarity, instead of just writing molarity, sometimes scientists put the bracket. So whenever you see the bracket, that means that stands for molarity. Instead of them writing molarity, so for example, if I have a number 3, that means that the molarity is 3 molar. How did I know? They didn't put the capital M, it's brackets over time, seconds. Okay? So they measure the change in concentration over time. Now, why is this important and why do scientists, especially chemists, study that? Well, they do study. Let's just erase, clear everything, and let's move on. So it is very, very important in research and development for pharmaceutical companies, for the development of drugs. For example, they're trying to find a drug to treat, for example, cancer. And they study the reactions that cancer cells perform. And they say, okay, we want to slow down or even stop the reactions that cancer cells perform in order for them to stop multiplying, okay, going through mitosis and producing more to stop cancer. So they study the chemical reactions, okay, and they say, how can I slow it down or even stop it for just the cancerous cells and leave the healthy cells alone? So that's a big one, okay, and they studied to develop drugs. So R&D is for research and development. Now, when it comes to kinetics, we know that it studies how fast the reaction takes place. Well, what you have to understand is, in order for a reaction to take place, okay, the particles must collide. So we explain how fast or how a reaction takes place by using the collision theory. So what do they say what do they mean when they say collision theory? Well, the word says it, collision. Particles or reactant particles must collide for a reaction to take place. So for a reaction, what does the collision theory state? For a reaction to take place, the particles must collide, okay? And that's what the word gives it away. So in order for a reaction to take place, what are we going to say? Reactants must collide. And you're going to hear us repeating it, and you may be able to repeat it, but I need you to understand what that means. So let's just write, in order for a reaction to take place, reactants must collide with enough energy and proper orientation. So you're going to remember that, you're going to write it over and over and over. Now let's understand, what does that mean? That reactants must collide with enough energy. If we click over here, you're going to see, we're going to go to a specific, it's going to take you to a specific site where you're going to be able to see this orientation. So I'm going to take you right now. So we see that the particles have to collide with enough energy. So for example, I have A2 and B2. Okay, so if I am to write, let's see if I can write over here. Okay, this A2 would be, let's say, look like this. That's a diatomic molecule. And then I have B2, and I have two atoms of the same, and that is my B2. Now, they have to form a new product, which is made up of one A and one B. So how is this going to take place? There is one, and there is another one. In order for this reaction to take place, the particles must collide, and this bond needs to break. So I have to break old bonds between these particles and these particles, these atoms, and form new ones. So in order for them to break these old bonds, these particles must collide with enough energy. So here we're going to have, let me just draw, we're going to have the reactants over here. Here are your reactants. And here are your products. What do I have? A, B, A, B. How did they form? Well, let's see. Let's play. They have to have enough energy. What type of energy? Kinetic energy. They have to collide with enough energy. When they don't collide with enough energy, nothing happens. Old bonds did not break. Okay? We have to break these bonds in order for them to collide. And I don't have enough energy. How about if I have enough energy? Look, they move faster. They were able to collide with enough energy to break old bonds. They're breaking the old bonds, and they just formed new bonds over here. Look what happens when they collide with low kinetic energy. They move slowly, and nothing happens. The collision is not enough for them to break these old bonds. These old bonds need to break, and in order for them to break, they have to collide with enough energy. How about if they collide with enough energy? Look, the bonds break, new bonds are forming. So that's what it means. Now let's move to the next part. So what did we say? Kinetics. Okay, collision theory, the particles must collide. Okay. And in order for them to break old bonds and form new ones, and they have to collide with enough energy, we saw that, and proper orientation. So let's see that one over here. Let me just clear my drawings. Here, we are having a chemical reaction. What is the chemical reactions? What are the reactants? So if we look at the reactants, okay? So what do we say? Reactants have to collide, break old bonds to form new products. What are my reactants? Well, my reactants is just K, there's my K, and CH3I. What are going to be the new products? The new product is going to be Ki and CH3. Okay? So what do we see? In order for this reaction to take place, the bond, and let me just change the color so you can see, the bond over here needs to break. This needs to be free so that it can be over here with Ka to form this new bond. Okay? So this old bond needs to break and a new bond needs to form. And in order for them to take place, they have to collide with enough energy, fast enough, forceful enough to break that old bond, and with proper orientation so that they can form the new bond. So let's see how is this going to take place. So if I am to go with incorrect orientation, okay, here they are, they're colliding, not with the correct orientation, okay? They're colliding. It has to collide with what? With the I, and it didn't. What did it collide with? It collided with a hydrogen. So that was not a correct orientation, okay? Because it has to collide with the I. Now look over here. Now they have the correct orientation. The old bond broke and a new one formed. So I have the link where you can go and you can watch it. And there we have the new products, the Ki and the CH. Okay, let's go back to, and let's see that in a new, let me just erase my drawing, in another one. Okay, so we're going to have the same reaction. So for example, we're going to have two diatomic molecules. We're going to have A2 and B2 forming 2AB. And what do we say? Old bonds need to break and new bonds need to form. So in other words, these A, the bonds, need to break. We see we have that's A and that is B, diatomic molecules. And these have to break. They have to collide with enough energy and proper orientation for them to form a new product. Okay? So old bonds need to break, new bonds need to form. And in order for that to take place, how does collision theory state? They have to collide with enough energy and proper orientation. So let's see this. So here are A and B. They have to collide to form a new product, okay? So they have to collide with enough energy and proper orientation. So here, they're going to collide with different orientations, okay? That's orientation 1 and orientation 2. So let's see. This is a correct orientation because the old ones broke. This is collided with the A collided with the B, the A collided with the B, the old bonds broke. But look at the old one, okay? Look at this one. We had no reaction because they didn't have the correct orientation. They didn't collide like this over here. So let's go back and see it. Okay, so let's look at the correct orientation. When they collide like that, that's the correct orientation. These bonds over here break and new ones form. So let's see that. Then it's a new product forming. That's the correct orientation. Look on the wrong orientation, okay? I have the link for this so you can go back and watch it on this. There we go, no change. So we can go back and we can say for a reaction to take place, reactants must collide. So we're going to write again, reactants must collide. Why do they have to collide? To break old bonds and form new bonds. And in order for this to take place, okay, so the reactants must collide. They have to have enough energy and proper orientation. I hope that makes sense and it's helpful. You're going to fill it in, you're going to write all that information, and you're going to upload it on Google Classroom. Have a nice day. Enjoy chemistry, enjoy kinetics and equilibrium. It is a fun topic, and it's also very, very easy, straightforward. Thank you.